Hello, Algebros. So today, again, we are going to be talking about some supplemental topics, getting us ready for tomorrow. Tomorrow we are going to be solving quadratic equations by completing the square. And when we complete the square, we create a perfect square trinomial. So tomorrow we are going to be creating this. Today we are going to be talking about how to factor them. So I'm going to show you kind of the long way to factor them and then an easier way to see what is going on. So the way that I teach factoring is we have an x and we take a times c, and in this case a is 1. So 1 times c, which is 16, would be 16, and that goes up here. Our b term goes down here. Notice I'm not putting any x's in my x. So you can kind of think of it as, oh, I already have an x, I don't need to write my x's. When we're factoring, we just worry about the coefficients. So now I need to figure out a value or a number that will multiply to get 16, but add to get positive 8. So if I think about the factors of 16, 16 can be factored into 1, 16, 2, 8, and 4 times 4. So if I think about that, 1 plus 16 would be 17. 2 plus 8 would be 10, but 4 plus 4 is 8. So my two factors are 4. So these become the factors, and it would factor into x plus 4 times x plus 4. Since they are the same, you can also write them as x plus 4 squared. And if you don't believe me, because you might be like, Miss Bauer, you just did some voodoo magic. I don't know what happened. Let's double check just to make sure we're right. So to multiply a binomial out, we're going to take the first values in both parentheses. X times x would be x squared. We're going to take the outside numbers, x times 4, which would be positive 4x. We're going to take our inside numbers. 4 times x would be another positive 4x. And then the last values in both parentheses, 4 times 4, would be positive 16. I have like terms right here that I can combine. So my final result would be x squared plus 8x plus 16, which, if you remember, is what we started with. So factoring is undoing that multiplication. So we're trying to figure out what two binomials multiply together to equal that trinomial. All right, let's do another one. So again, we're going to take a times c, in this case 1 times 9, which is 9. And our b term is negative 6. So I'm going to look at the factors of 9, which 9 factors into 1, 9, and then 3 times 3. So I want to know what values add to 6 that multiply to 9. Well, 1 plus 9 would be 10, but 3 plus 3 would be 6, but we want it to add to a negative 6. So both values are going to be negative because we know a negative times a negative is a positive, and a negative plus a negative would still be negative. So those are our factors. So we're going to use our variable up here, and we have n minus 3 times n minus 3. And again, because these are exactly the same, we can write it like this. And again, you're like, whoa, Miss Bauer, that was some voodoo math magic. Let's make sure that you are correct. So let's go ahead and multiply these out. We're going to take the first values, n times n, which is n squared, times the outside values. N times negative 3 would be negative 3n. Negative 3 times n would be negative 3n. And negative 3 times negative 3 would be positive 9. Combine your like terms. N squared minus 6n plus 9 is what we started with. All right, let's take a look at number 3. a times 16. 1 times 16 would be 16. And my b term is negative 8. So I already factored 16 up here. So again, we're looking for values that add to an 8, but this time it adds to a negative 8, but still multiplies to a positive 16. So it's a lot like number 1. The difference is it adds to that negative 8. So both factors are going to be negative. So those become our two factors. So we have m minus 4 times m minus 4. And again, they're the exact same, so we can write it as m minus 4 squared. Let's do one more where we write it all out. We have 1 times 1, which is 1, and then our b term is 2. So the only factors of 1 are itself. And luckily for us, 1 plus 1 is 2, and 1 times 1 is 1. So our factors are 1 here. So our two binomials that would multiply to this trinomial would be a plus 1 times a plus 1. And again, they're exactly the same, so we can simplify that and write it more compactly. All right, let's see if you can see a pattern yet. So far, our last number has been a perfect square. And our numbers inside our parentheses are half of our b term. So if we know that the square root of 9 is 3, and also 6 divided by 2 is 3, we can just look at that and know that the square root of 9 is 3. So it makes that factoring of a perfect trinomial a little easier. So remember, that only works if that last number in the trinomial is a perfect square and the square root is half of our b term. So here we take the square root of 4, which is 2, and then our b term is 4. Take 4 divided by 2, which is 2. So because that is true, it's going to factor into x plus 2 times x plus 2, which you can simplify as x plus 2 squared. Let's do one more where we're just kind of looking at our a and our b and c terms. So our c term, the square root of 25 would be 5, and then we take our b term and divide by 2, and 10 divided by 2 would be 5. So since those numbers are the same, we know we're dealing with a perfect square trinomial. So our numbers are going to be n and 5. But remember, they have to add to that negative 10. So it's n minus 5 times n minus 5, and we can simplify it and write it like that. Perfect square trinomials are going to follow this pattern every time. And as I said, tomorrow we're going to be completing the square, which means that we are going to be creating a perfect square trinomial. So this is just a reminder on how to factor those perfect square trinomials.